Hello everyone, I'm Shaunik Jog, and I'm here with Mr. Stefan Tarnutzer, President of AVL Mobility Technologies. Mr. Tarnutzer, would you like to tell us a bit more about your background and industry?
All right. So what I want to talk about, which should be very interesting for all of you, is the mobility technology space. So mobility can be defined in anything that moves persons, moves people, moves goods, moves us from a point A to a point B, or brings us goods from a point A to our home or to wherever we deliver it to. And the mobility behind it are either vehicles that are driving on the ground, on the water, underground in some cases, flying, or potentially even going to the moon. And the mobility space really has changed tremendously over the last 10 to 15 years, not only from an electric vehicle perspective that probably most of us are familiar with, but also from a perspective of how we're going again now back to the moon. Many different countries want to go back to the moon with traditional methods, but there's also now many more types of ideas people have that they not only want to go to the moon, for example, they also want to go to Mars, and they want to repopulate or populate the moon and then potentially also populate Mars. So mobility as we know it from maybe before that it was a bicycle, a motorcycle, a bus, a passenger vehicle, has expanded tremendously as we talk mobility to also now drones, eVTOLs, advanced airplanes that may not just drive on fuel or fly on fuel, but also fly on electric with electric batteries and hydrogen through fuel cell technology. So again, the mobility space has tremendously changed, and I'm going to share a little bit over the next 10 to 15 minutes about that. So who is this guy who's talking? I come with a fairly diverse background. I grew up in Europe, in Switzerland. I went to engineering school there, got my electrical engineering degree there, then came to the United States and studied management and economics, and got my MBA at both Oakland and then a post-MBA degree at the University of Northwestern at the Kellogg School of Management. And from then on, I started leading different technology companies, mainly in the mobility space and mainly in the passenger vehicle and heavy duty space. And then I would say over the last 5, maybe 10 years, have consistently expanded my leadership responsibilities, but also the type of areas that I'm responsible for, to have background in ADAS and autonomous driving, background in electric mobility and electric vehicles, fuel cell vehicles, but also fuel cell as it relates to how do you create hydrogen that's necessary to go into a fuel cell to generate electricity. So electrolyzers is that equipment is called, and have worked on a variety of different projects. And one of the most exciting projects that I can share a little bit later about maybe is that we're now working on a program with NASA to put a vehicle, an electric vehicle, onto the moon, and it's called the Lunar Terrain Vehicle. But to maybe jump back a little bit and highlight the company I work for, AVL, or AVL Mobility Technologies. We're a technology company and we're a product company. So on one side, we develop new mobility technologies. Is that a new battery? Is it a new motor? Is it a new engine? Is it a new chassis that can maybe then go not only on the road, but maybe also go on water? So float on water, drive on water, bring the wheels out, move onto land, drive on land. You could think military vehicle, but you also could think like entertainment vehicle or fun over the weekend type vehicles that people may want. So any sorts of those types of technology we develop. But then we also develop test equipment that can test that new vehicle, that new component for an autonomous vehicle, for an electric vehicle, for a fuel cell vehicle, but also for traditional diesel and gasoline vehicles, for anything from a two-wheel scooter that you may have in India or in Asia, all the way to a heavy-duty truck or large trucks that are used in mining, in agricultural, military applications, but also on-high deliveries that we see, for example, in the United States, driving goods from the West Coast to the East Coast and from the North to the South. And then we also have an organization that works on simulation technologies, which is a key enabler and really has allowed the mobility space to tremendously move ahead and allow its tremendously fast progress to where it is today, where we're scratching the surface of often electric vehicles that can go 600, 700, 800 miles on a full charge and then can be charged in maybe 5 or less than 10 minutes, very similar to a diesel or gasoline engine could. So those are just some of the examples of the products and technologies that we have as an organization. We're an industry-wide value creation organization. So oftentimes companies are coming to us and say, we have a need to develop a new gadget, a new technology, a new feature in a vehicle, on a plane, in a boat, in an airplane, whatever it might be. You kind of see that on the lower left side here with the different type of symbols we have for the different types of mobility vehicles we work on. And then AVL comes along, brings technology know-how, brings capability, brings intellectual property and development know-how to develop these technologies and help our customers bring these new tools, these new products, these new vehicles to market. Overall, we're over 12,000 people globally. We're represented in over 26 countries. We have 45 global tech centers. And last year we celebrated our 75-year anniversary, which was very exciting. AVL started after the Second World War in Europe as a company that helped develop and innovate diesel engines, which was the main means of propulsion systems back in the days. And since then has tremendously grown into a very large organization that spends a tremendous amount of money on research and development, a tremendous amount of money in patents and IP, because we feel that is one of our key differentiators. And what we do with this is then, as part of our global network, we're really focusing on working with the companies that are at the forefront of technology development. So in Silicon Valley or in California, you have a number of different startups. You have Tesla, very well known. You have Rivian, you have Lucid, you have some smaller organizations that are there. In the middle of the country or more east in Detroit, you have all the major, almost all global OEMs. In Europe, you have a lot of the European OEMs heavily populated, obviously with Mercedes, BMW, VW, a lot of the French companies, some of the UK companies. And obviously in Asia, you have big players in Japan with a Honda and a Toyota. In South Korea, you have Hyundai. And in China, you have a multitude of new players and older players. So very similar to what we see in California, tremendous startup scene with new EV-focused OEMs in the passenger vehicle side. You also have this now in China. And with our global network, as you can see here on this map, we're supporting all these OEMs, not only on the passenger vehicle side, but also, again, two-wheelers that we do a lot of it in India with Mahindra and some of the other companies that are there, for example, and in China as well with a lot of the startups there, BYD, Geely, just to name a few, and obviously also then in Asia where we help, again, from two-wheelers to passenger vehicles to medium-duty truck that you use sort of for last-mile delivery trucks. Think Amazon trucks, UPS trucks, FedEx trucks in the US, to all the way to heavy-duty trucks. Those are the big wigs on the road with sometimes 2 trailers or more, depending on what state you're in, that are allowed to drive on the roads. We help them with anything from engine development to transmission development to battery development, ADAS and autonomous software and features and functions, and almost anything that has to do with technology in a vehicle, which is today heavily driven by software. You may have heard the term software-defined vehicle. Think an iPhone or an Android on wheels, so you can download things, you can customize your phone. Now that turns into your vehicle. You can customize it to your liking. And over the last year or two, artificial intelligence, but certainly also machine learning now has become more or less part of every new vehicle that comes out onto the road. Again, from two-wheelers all the way to heavy-duty trucks. But I think the interesting thing is And mobility is changing super fast. As I mentioned, 5-10 years ago, EVs, specifically in California in this country, a little bit in Europe, and not much yet in China, for example, started to come up, but it was still more focused on hybrids. But then, when you compare that even then with 15 years ago, nobody was really talking about EVs. EVs existed. Ford, for example, had an EV at the turn of the century, so at around the 1900s. EVs then came up again in the 1970s and 80s, but it was more sort of an exploration into would it be possible, is the technology ready, and it wasn't until about 5, maybe a little bit more years ago, maybe 10 years ago, with Tesla again really pushing forward, pushing into this space, and really ringing the bell or starting the race of mobility changing tremendously again. Because not only were EVs coming onto the market, but we also had ADAS or autonomous driving coming on the market. Think Waymo in this country, think Pony, think Baidu in China, companies that are heavily focused on not only using AI, but using autonomous vehicles to move people, think autonomous taxis, but also to move goods autonomously, to address the driver shortage that exists in heavy-duty trucks and last-mile deliveries, and to avoid the heavy costs associated with drivers to deliver your goods and services to your doorstep. So really, 10 years ago, 2 major mega trends happened that really changed mobility forever, as I see it. Because if you look on those pictures here, for example, an electric plane on the top left, nobody was thinking about that 5 or 10 years ago, maybe. Boats, kind of you see it in the middle, so heavy ships. Nobody thought about making propulsion systems for boats based on fuel cells and hydrogen. It was always diesel or other types of fuels, but not hydrogen that is sustainable, that if produced in a green way, can have a zero impact on the environment. And we're looking at racing, for example. Racing now is pushing heavily into electric vehicle racing, so not gasoline anymore, but electric vehicle racing. We're looking at every major OEM or every OEM in the world coming out with more and more electric vehicles. 10 years ago, nobody was ever imagining this. And again, as I sort of mentioned at the beginning, we now also have NASA looking at it, not only going back to the moon, so starting mobility again and jumping in this rapidly changing environment of mobility, but they want to go to the moon and they want to put an electric vehicle onto the moon that allows the astronauts to drive around and further explore the moon, its surface, and what it may or may not hold for us going forward into the future. But we also have drones that can be used for delivering of goods and services in remote areas, for example, maybe in Africa, to do humanitarian help, to bring medicine in remote areas, to bring spare parts to maybe an island or to a boat that's stranded out in the middle of the ocean. Technology has enabled a tremendous amount of things. And what happens with technology and mobility together is this mega trend, these tremendous changes we have seen over the last 10 years. And what obviously comes with this is the necessity for all the companies that are part of the ecosystem, so all the different suppliers that make a vehicle happen, that make a plane happen, that design it, that build it, that test it, that fly it. Same is true for passenger vehicles, for heavy-duty trucks, for military, for drones, for eVTOLs, for traditional helicopters, all of these things. With all that, everything was shaken up. A lot of things are changing. Bring in software. Everything today is more important and more capable with software and for software. That is also something that really changed about 10, maybe 15 years ago, making software so much more important than it ever is. And what does this mean for companies? It means change, consistent changes. Where 15 years ago, maybe the most important person in a mobility company was a mechanical engineer, because a vehicle, any type of vehicle, again, on the ground, on the water, in the air, was heavily focused on mechanical functionality. That has shifted today to electronics and software. So suddenly you have a different type of engineer you're working with, or that dominates your engineering force. The speed at which new vehicles are developed, it used to be 4 or 5, maybe more years it took for a new vehicle, a new mobility function or feature to come onto the market, to be available to be purchased. That now has changed. Now it is 3, maybe even 2 years, so super fast. So what does this all mean? Tremendous changes in how you lead a company. That at the end of the day is really where my passion comes in as it relates to leading through change, because leading through change can be very, very difficult, and it is very, very difficult. It can be super challenging. It can be very frustrating in many cases. It can be hard to push forward, to push through technological barriers, to technological challenges. But at the end of the day, the challenge is where my passion is. How can I, together with my team, how can we as one team, as one organization, together bring minds together, bring capabilities together, bring people from different backgrounds, from different educational backgrounds and different schooling and different disciplines. How can we bring that together to develop new technologies, to better these technologies, to make them more sustainable, to make them more user-friendly, and also to make them more safer. All this together with all these mega trends that I was just talking about over the last 5 or 10 years, 5 or 10 minutes, has made my journey and the journey of the different teams that I've led or been privileged and blessed to be part of so much more rewarding, but also so much more exciting, which then kind of allows a lot of different individuals with a lot of different passions to come together, similar to how a sports team comes together to achieve, to get to the next level and ultimately win a championship, and in this case, ultimately develop technology that then goes into many different vehicles and makes the world a better place and makes a lot of people happy because they enjoy driving the vehicle or enjoy getting goods and services delivered faster, less expensive, in a safer manner. There's a lot of joy behind it. There's a lot of sweat and tears behind it because it's challenging oftentimes and not always easy to push through. But at the end of the day, leading through change can be super rewarding. It has been for me, despite the challenges. I love challenges, and the teams that I have built and have been around me and I have joined myself, they all have a challenge and a passion, and it is to develop the technologies of tomorrow today. And this has been our mantra, so to speak, over the last 5 years or 6 years since I've joined AVL, that we want to look forward to developing the technologies of tomorrow that are safer, more sustainable, more environmentally friendly, but also better, higher quality. We want to develop those technologies tomorrow, today.
Yeah, thank you so much again, Mr. Tarnutzer, for coming in and presenting for us. That presentation was amazing and really insightful. So moving into the Q&A, the first question that we have for you today is, what drew you into working with the field of automotive engineering?
Well, I'd say the field of automotive it's a great question because it's a funny answer I'm going to give you. I never cared about vehicles. I actually never did. When I studied electrical engineering and then had the opportunity because of a basketball scholarship that I got to come to the United States, I obviously needed a car because I needed to get from point A to point B. But I always felt like cars are boring. I always felt like, what is there? There's an engine, there's a steering wheel, there's a gas pedal, there's a brake, there's a few doors. What can be exciting about it? And then I got to know my girlfriend, my wife now, and she lived in Detroit. So we decided when we got married to move to Detroit because my teachers told me, hey, you know, you speak English, you speak German, you speak French, you have an electrical engineering degree, now you have a management and economics degree, you should really go to Detroit. I think you would easily find a job. Well, seems like a great fit. My wife is from there, we moved there. And I started working in the automotive space more out of a necessity because that's really the biggest industry that's in Detroit. But I would say within 2 years, I fell in love with not the mechanical side or any particular side of automotive, but with the complexity behind the vehicle, behind passenger vehicles and heavy duty trucks, because it was so fascinating, where I always felt the computer, things they were doing in Silicon Valley already back then in California, that I always felt like I want to work in that again, or I work in the cell phone space that started to come up during the early 2000s. But I really fell in love with automotive because the technology behind the vehicle, though hidden, was so much more complex than what's in a computer, so much more complex. It's in a cell phone, even as old as a cell phone 25 years ago. And I just fell in love with the technology and how more and more features and functions would be added to the vehicle through what I studied, electronics. And I just got excited about it. I got excited about how complex it is of a product to put a vehicle together. Again, be it as a plane, be it a ship, or again, mainly what I dealt with is passenger vehicles and medium and heavy duty trucks. And I just fell in love with the technology.
Wow, yeah, that's really interesting. So in your presentation, you had also mentioned working with NASA to create a lunar terrain vehicle. So could you expand a bit more on that?
Sure. So we've been working with different companies to respond to a NASA request on not only going back to the moon and bringing astronauts back to the moon instead of unmanned moon missions that since the 70s have occurred on a regular basis, more or less. And so not only also bringing robots up there, but bringing, again, astronauts, people, humans, up to the moon again. But they wanted to put a vehicle up there. They needed a vehicle because they didn't want to just be restricted to a short distance from the landing vehicle that would land on the moon, but they wanted them to be able to get on this vehicle and just on Earth drive around. Obviously, a significant amount of totally different challenges you have on the moon. Temperature swings of plus minus 50 degrees Celsius, depending on if the sunlight is on your moon or if in the shade of the moon. The sand's super fine. The terrain, which is very unknown and very rough on any type of mechanical or electrical component, makes this type of vehicle, the lunar terrain vehicle, an even larger challenge. And then also we can't bring fuel up there. So how are we going to power it? The answer is electric vehicles that then can, through solar panels, recharged again, or other cells up there recharged again, to again allow the human space explorer, moon explorers, to drive around, collect samples, do experiments. But the challenge obviously is to get this vehicle developed that it's going to last for 5 or 10 years without having to be repaired, at least significantly. Because as opposed to the Earth, you can't just drive 5 miles to get to a dealership or a garage where they might be able to quickly fix something. It's a long way up to the moon and very expensive and very cumbersome and time consuming to do that. So that makes this challenge a tremendous amount of challenge, not only from how do you put it together, how do you maintain it, and how do you ship it up, but obviously from the beginning, how do you design all of these things to last in an environment that's very unknown, very challenging, but also how do you make it so you can put it in a rocket, get this vehicle up there, and then get it deployed.
Wow, yeah, that sounds amazing. Working off of the stuff that you had mentioned about electric vehicles, how is it possible to increase the range efficiency of electric vehicles?
Very good question. So range efficiency is, oftentimes people talk about it's all to do with the battery and the battery cell, which then either you put in a pack or in a module, but a battery cell, hundreds if not thousands of battery cells make up the battery of a vehicle. And many people think it's all about the battery and the chemistry of this battery. And that's certainly true. Today, the majority of batteries used are lithium-ion type batteries and small or slight variations of it. We're pushing now into semi-solid state or solid state batteries. They're not only safer, but they can also have a higher energy density. And that certainly is the future, and we need to push, and many OEMs pushing for it. And those batteries exist. The challenge is they're not necessarily ready yet for mass production, which in automotive, with hundreds or thousands of individual battery cells for each vehicle, you have to be able to mass produce things or it's not cost efficient or effective. But besides the battery, there are so many other components, an e-axle or an e-motor, the inverter, the thermal management system that you need, because a battery, most battery chemistries used today have a very relatively narrow range of what temperature they're best functioning. You may have read that some Teslas or other types of vehicles from traditional OEMs or from the startups, they do great, for example, in places like Texas, they do great in places like California, but in places like Michigan, where I'm at, where in the summer right now it is 80 degrees, but in the winter it can go -10, -20. The range of these vehicles varies tremendously, and it has to do with the thermal management, because then the vehicle's battery spends a lot of time when you start driving for the first 20, maybe even more minutes, depending on how cold it is, to set a temperature for this battery pack in your vehicle, to get these batteries into a thermal range, into a temperature range, where it can be optimally using and dispensing, so to speak, energy. That also then impacts how you charge the vehicle, again, how it drives the vehicle. But with then, again, you may have read that in the winter, ranges of electric vehicles go significantly down, and in the summer they go tremendously up. My electric vehicle in the winter maybe goes about 50 miles of range, or 60 or 70 miles of range less than it does in the summer when it's 75, 80 degrees Fahrenheit. And that is one of the challenges that, again, is associated with thermal management. So besides battery cells, thermal management, and just the entire thermal system and energy usage system, energy efficiency usage of all the other components you have in a vehicle, of your heated or cooled seats, of your heated steering wheel, of your infotainment system, of your ADAS and navigation system that uses different sensors in your vehicle. All of these things are energy consumers, and the more efficient those individual energy consumers are, the less they need to use from the battery, which means the more of that battery power or capacity can be used to drive the vehicle further. So that's then helps with range.
Wow, yeah, that makes a lot of sense. So the last question that we have for you today is, how can high schoolers that are interested in automotive engineering get further integrated into the career path?
I would say buy magazines, go online. You don't even have to buy them anymore. You can go online, read about automotive technologies to really, kind of like me. I didn't have that opportunity back then. In 95, when I came to the United States, the internet was not really there yet. And then with 2 years later, it started to slowly come. But we still went to the library or bought magazines. Today, you have the internet at the fingertips. So depending on what you enjoy, kind of like with my story in the background, don't eliminate any type of area where technology is, or maybe where you're not sure at. Look at the things, research some things, use the internet. And then I would say one of the best things you can do is to listen to things, what you guys are taping here. Go online, listen to podcasts, listen to YouTube videos of people or companies that share about their technologies that go into a vehicle. Again, something's on the ground, something on water, in the air, going to space. And then last but not least, I encourage you, reach out to executives, reach out to companies' human resources department, and see if there are internships available. You don't need to be an intern necessarily only starting to do that when you're in college. In high school, there's many times you can do 1 or 2 day trips. There's sometimes open forums that different organizations have to get kids more excited about technology and familiar with different technologies. And companies today are very eager to get their hands on new talent that is in high school and in college both. But get familiar with these companies, look at what areas you're interested in, and don't shy away to go into one technology field, and then maybe after 5 or 10 years in that field, then you go to the next one again. So don't think in high school you have to make a decision what exactly you're going to study in college or where exactly you're going to work. Get an idea of what excites you: software, hardware, mechanical. Mechanical engineers will always be needed, even though everybody talks about software. So don't get discouraged when you're more mechanically inclined. instead of feeling like you're just wanting to write in C, C++, that you rather want to do something mechanically more focused. There's still a tremendous amount of need for them, and I think it's going to be always there, because software without any hardware, electronics hardware, any mechanical thing is not really going to do anything. So go into that field, study it, and once you're in the engineering field, I have many people on my team that studied maybe mechanical engineering that today are software engineers, or software engineers that today look at forward planning for thermal management type of applications. Engineering is a beautiful field because it really gives you such a great foundation to go into so many different fields. And even if you don't like engineering anymore, there's always the management path. That's really where I went down to, because I knew after my electrical engineering degree and doing this for about 5 or 8 years, I'm like, I'd rather deal with people. I want to deal with people. I love interacting with people. I love leading people. Kind of what I said, I love leading people, leading teams through technical challenges or challenges to grow and get to the next level, right? So you have that ability, but I also know a lot of engineers that when suddenly they decided to become a lawyer or go into all sorts of other fields. And education will always get you to the next step. And it's a great springboard to do a lot of different things that you may not even know today you're going to do 5 or 10 years from now. I'm one example. I never thought I would like vehicles. Today I love vehicles and I love the technology behind them.
All right. Well, that's all we have for today. Once again, thank you, Mr. Tarnutzer, for agreeing to the interview. And we'll see you all next time. Bye.
Thank you. Bye-bye.